So today I'm going to be talking about ABGs, arterial blood gases. And to start off, I want to mention that pH stands for potential hydrogen, so make sure you guys mention that. And the next thing is an Allen's test. The Allen's test is a perfusion assessment of the radial and ulnar artery. So when we access the radial artery, the ulnar artery hopefully is still patent enough to perfuse the hand in case something goes wrong, something like a thrombus. So remember the Allen's test, okay guys? And then we'll talk about the way that the body maintains pH. So first of all, I want you guys to know that pH is like temperature, let's say. Not that it has anything to do with temperature, but in order for your body to maintain homeostasis, it has to be in a therapeutic value of temperature, 98.6. If it goes too high or too low, you can't carry out metabolic processes. Well, the pH is kind of the same thing. The pH has to be between 7.35 and 7.45 in order for metabolic processes to be carried out. So when you're too cold, your body shivers and it creates heat, you warm up. When you're too hot, you sweat and it cools down. And well, the pH kind of works the same way. We have two basic elements that maintain pH. We're talking about the lungs and the kidneys. And they're essentially small molecules of carbon dioxide and HCO3 or bicarb. And we call those the buffer system. And they go throughout the blood, regulating or buffering out the pH to make sure that it's always at 7.35 to 7.45. Which brings us to our next thing. So we talked about the pH. The lungs control the carbon dioxide. You have to know the therapeutic values. Carbon dioxide is 35 to 45. If you guys have a hard time remembering that, just make sure that you bring down the 35 and the 45 from the pH. It gives you the therapeutic value. And then we have HCO3 or bicarbonate, and that is 22 to 26. So make sure you guys memorize those values. If you don't know those values, you're not going to get the question right. And to start off, CO2. If the CO2 is too low, it's a respiratory issue, and it's respiratory alkalosis. If it's below 35, excuse me. If it's above 45, it's a respiratory acidosis issue. The HCO3, if it's below 22, it becomes a metabolic acidosis issue. And when it's above 26, it becomes a metabolic alkalosis issue. So make sure you guys keep those things in mind. Another thing that people get confused with is the pH. If it's high, what does that mean? If it's low, what does it mean? Well, we can look at this. If the pH is above 7.35, it becomes alkalosis or basic. I'm going to be referring to it as basic or base. When the pH goes below 7.35, we start becoming more acidic and we go into the region of acidosis. So what I did was I created three basic problems so we can kind of play with it and see how you work these out. The first one shows the pH, CO2, and HCO3. We have to interpret every one of these one at a time so we can kind of figure out what's going on. So the pH being 7.14, we know that it's low, so we know it's acidosis, or it's acidotic, or it's acidic. Then we interpret the carbon dioxide. Now, remember we mentioned that if the CO2 is high, it's acidosis and it's a respiratory issue. So we're going to work with that first. Looking at the CO2, it's 52, it's above 45, so this is, real quick, respiratory acidosis, right? But we're just focusing on the CO2 right now, and I'll bring it all together in just a bit. And the HCO3 is 24. It's actually normal. So we can figure out that the pH is low because there's too much carbon dioxide, and it coincides with the actual result. So it becomes respiratory acidosis. The next problem shows the pH of 7.51. Let's interpret each one of these at a time also. So 7.51, we know this is alkalosis, or basic. Then we want to interpret the CO2 by itself right now. So it's above 45, so we know that this is respiratory, just this part right here, okay guys? Respiratory acidosis, because it's above 45. And then let's interpret the HCO3 or the bicarb. It's 38. It's above 26, so we know that this is metabolic alkalosis. So to figure out essentially what the actual pH interpretation is, you want to find out which of these two coincides with the abnormal pH. Well, since it's 7.51, we determine that this is alkalosis. Well, it's a metabolic issue, and it becomes metabolic alkalosis. And then for the third sample that we have, it's a little bit different. We start getting into the lines of compensation and elements like that. So the pH is 7.42. If you guys recall, this is well within the therapeutic range, so this is normal. And then we go into these abnormal values of CO2 and HCO3. So if we look at the CO2, it's 52. We know that that's elevated. We know that's acidic. And that's also a respiratory issue by itself. And then when we move on to the bicarb, it's 39. That's also elevated. And we know that's alkalosis. And that would be a metabolic issue. When you have these problems that both the CO2 and the bicarbonate are abnormal, but the pH is normal, we get into something called compensation. Whatever was happening, it actually compensated. The pH went back to normal, so we're actually okay. But we still want to find out what was the issue. When it comes to figuring out what the issue is, you have to do some basic arithmetic. You got to recall that the normal CO2 is 35 to 45, and I'll write that down right here, 35 to 45. And you want to find out the median number. So between the middle number between 35 and 45 will be 40. You get that 52, you subtract 40 from it, and it gives you 12. So we know that the CO2 is off by 12 points. Then we go to the HCO3, and we kind of do the same thing. We play with the numbers with the therapeutic value of HCO3, which is 22 to 26. The middle number is what? 24. So what we do is we get 39, we subtract 24, and it gives us 15. So HCO3 is off by 15 points. And this is how we find out. It's compensated, right? The pH is normal, but it's actually a metabolic issue, or it was a metabolic issue that caused the abnormality. But the CO2 started going up because the body's trying to compensate for the fact that the HCO3 is elevated. So the CO2 is saying, hey, I'm going to elevate that too, so it can normalize and hopefully compensate the pH, and it's exactly what happened. Okay, guys? So I hope you kind of understood this. I'm going to be posting more videos. Please follow me on NCLEX.Solved in my Instagram, same thing with Facebook, and I hope to see a lot of you guys around. Thank you.